Welcome to Jonathan Gomez and Miranda Ward's project for CS2316 about competitive college swimming data. You might be wondering who I am. I am Jonathan Gomez's personal assistant named Jarvis after the artificial intelligence in Iron Man, and Jonathan asked me to introduce his project today. Opening the slides presentation now. How they chose their topic, you might ask. Miranda and Jonathan were both competitive swimmers in high school. They love the sport and they were excited to analyze how college swimming time data has changed over the years. Have swimmers gotten faster? Have they gotten slower? How does location and gender affect time swum? They were also excited to work with a huge compiled CSV of time data in tandem with a JSON file of team names. I now present Miranda Ward.
Yes, so we started off by collecting various data. We had two essential sources of data. The first was the college swimming website, which had a HTML page that linked to a new page for each event for each swim season. So within the season, you could find every event that exists, and within each event, you could find a CSV file with all of the times compiled for the entire season. Within each CSV, you had swimmer rank, swimmer first and last name, team abbreviation, time swum, and date swum. And that was the big data, tons of CSV files on that site. Our second main data source was the college club swimming site's JSON file full of team data, registration data, and their locations. So that had their abbreviations, their team name, all of that. And we use those in tandem to conduct our project. So to web scrape the CSV.
So how we web scrape the CSV, I have, you can see 4 different lists at the top of web parser 1. I went through every possible combination of those lists in a for loop, in multiple for loops, and iterated through each one and edited each row iteratively. And this is what it looks like whenever I was finished each row, and each this number on the side is the rank in that stroke in that season on that competition. And it shows gender and lap length and all the information that you need.
And then this was our final JSON file, just extracted that location and team abbreviation information, essentially. So for cleaning the data, we first started by cleaning the JSON file. And so as that JSON file showed, it had the college name and the city and state together with white space in between. So we stripped that white space, extracted the college name, the city and the state, and then made a dictionary for only the registered teams, and that dictionary consisted of a mapping of the team abbreviations to the college, university, and name, as well as their city and state, which looks like this once it was all cleaned up. And then for web scraping the CSV, pretty much all we did here was convert the time to seconds so that we could then perform later calculations on that data, and then we wrote that to a new CSV. And then together, we cleaned the combined CSV and JSON, merged them together, and essentially just added a new header with the college university column, the college city column, and then the registration status, and then iterated through and merged those two files together so that all of the information could be in one place moving forward for our analysis. This is what that clean file looks like. Again, there's all of the JSON data on the rightmost side of that CSV.
And it should also be noted that the hashtags seen under date are just because of the CSV that we were looking at. Those hashtags should actually have the data information. Yes. So for data analysis, insights, and visuals, I'm going to go over the data analysis and visual with the GUI. So there's multiple different. So this is the GUI that I created. There's a bunch of different combinations that you can create. You can pick back, rest, fly, free, and you can only select one of each. And it creates different graphs. So for example, 50 back, all individual times, click on results. It shows you this table with the same thing that you saw in the CSV file.
Real quick to interject, if you'll notice, the top swimmer is from Georgia Tech Swim Club.
Yes.
Just want to throw that out there.
It is. So another type of thing that I did is average time. So if you select average time, same format. You can do multiple. I'll show you rest. I'll just change it to prove a point. If you click on results, it changes this, and then if you click on graph, it shows you a line graph of the average times for each season. for the 50 breaths, and all this is individualized for each possible graph. Another type of graph is the bar graph. So if you select on male and female graph, it shows you male and female average times for each season, also individualized. And then the last type of graph is the location graph. I'll just change it so that you can see, you can select whatever you want. I'll change this to 100 fly and top 100. So if you click on graph, it opens it in Google Chrome. And I will explain how this works later. Sadly, I cannot go over so this just shows like a heat map of all the best times. Here, Delaware has the best times, and probably Arizona has the worst. It's just a heat map of all the average times. Sadly, I can't go over too much how the code works. I would highly recommend you to play with it after. It's a lot of work went into this, and it was a lot of fun to make, and I was very happy that I did it. It's 542 lines. I'd just like to interject that. And then the next thing that we're going to talk about is, if you look at, I have some examples here of the different types of graphs that you can make. So there's the bar graph that you saw before. This just has 200 IM, which is a different type of stroke for males and females, another line graph, and the maps that I showed you.
Yeah, so from the combination of the graphs and various data analysis, we came up with several insights. Our first one was found through comparing 3 different men's events, all in freestyle. So we compared the 50 free, 100 free, and 200 free. And what we found was when comparing across multiple seasons, there was this spike of slowness from the 2020 to 2021 season. We attributed this to, since we were analyzing the top 100 swimmers, they probably didn't have time to train and compete in their championship time since COVID hit right before swimming championships start. So those top times were probably taken from slower meets earlier in the year, which probably explains why swimmers appear to be slower in this year.
And our second insight is, so whenever you look at male and female, the bar graph that I showed you, you can see that males and females on average have, females are slower on average than males just because of physique. And during the 2020-2021 season, you can see this slowness because of what Miranda spoke about before.
Yes, and then our third insight is kind of unique in that it was a little more code heavy, but it was comparing the difference in average times between men and women for each 100-yard stroke that exists. So we compared 100 free, 100 back, 100 breast, and 100 fly. On average, the difference between the average times tended to be at about 8 seconds, 8.5 seconds between men and women, with the exception of the 100 breaststroke, where the time difference tends to be closer to 10.5. Again, we contribute this probably to physique differences and just the mechanics of the stroke itself, but it is really interesting that 3 of the 4 were really close, and then 100 breast was just 2 seconds off for some reason. So that was a very interesting insight that we gathered. And then our fourth insight seems to be kind of at odds with our first one. We again compared each stroke option between men and women, except this time we looked at all swimmers. So previously we looked at those top swimmers, and that's where we saw that slow spike for the COVID season. This time we see a fast spike for the COVID season. And so what we think caused this is that because of COVID, because there were probably limitations to the amount of people that could race, you probably had more of the faster swimmers competing overall, which reduce those slower outliers that would contribute to a slower time. And so we actually see a faster time for the total swim data when compared.
So then the last insight, we compared 50-yard backstroke by location. We found that Washington State had the lowest one at 37.51, and Wyoming had the fastest. You can see that in the heat map. The darkest is Washington, the lightest is Wyoming. Overall results in conclusion. So I learned about new GUI modules. GroupBox allows me to put checkboxes in a group so that they're not all, I can select multiple. Table view allows me to see a table on the GUI. Abstract table model allows me to put a pandas data frame into a table that can be used by QTable view. And the coral graph is the graph that you saw with the heat map. Thank you very much.